Okay, let's dive into this. It's a really cool chemical transformation. We're going to break down a reaction that, honestly, it looks like pure magic. But what you'll see is that it's actually some really elegant, predictable chemistry.
I mean, have you ever seen something like this? You take a shiny metal, heat it up a bit, and poof, it turns this dull, flat black. Wild, right? But what if I told you we could reverse the spell? That we could turn it right back into that shiny metal again? Well, that's exactly what we're going to get into.
Okay, first things first. Let's look at part one of this whole thing, witnessing that first, really dramatic change.
So, the setup here? Super simple. All we're doing is taking some of that reddish-brown copper powder, you know the stuff, and we're just heating it. That's it. Nothing else is being added. Just heat and, well, the air that's all around us. So, what do you think is going to happen?
And boom, there it is. Almost instantly, the surface just changes. That shiny reddish-brown color? Gone. And in its place is this deep, kind of matte black coating. It's a total transformation. So, what in the world just happened here on a chemical level?
Well, this incredible change has a name. It's a super important chemical process called oxidation. And all that really means, in this case, is that our copper has gained oxygen. The heat we added just gave those little copper atoms enough energy to grab onto the oxygen that was just hanging out in the air.
And here's what that looks like as a chemical equation. You see on the left, you've got your copper, Cu, and it's reacting with oxygen from the air, O2. When you heat them up, they combine to make this brand new thing on the right, copper oxide, or CuO. That's the black stuff. It's not copper anymore, it's a whole new substance. So our original copper is kind of gone, right? It's been transformed, locked away inside this new black stuff. But is that it? Is the change permanent? Or can we somehow break it apart and get our shiny copper back? Well, let's find out. All right, for round two, we take that black copper oxide we just made, and we're going to pass some hydrogen gas right over it while it's still hot. So we're introducing a new player into the mix here, hydrogen. Let's see what it does. And would you look at that? It's amazing. It's like we're playing the movie in reverse. As that hydrogen gas passes over the surface, the black coating just disappears. And what's left behind? Our original reddish-brown copper. We actually did it. We reversed the reaction.
Okay, so this awesome reversal process has a name too. It's the perfect partner to what we saw earlier, and it's called reduction. It's super simple. If oxidation is when something gains oxygen, reduction is when something loses oxygen. The copper oxide lost its oxygen, so we say it's been reduced back to pure copper.
So here's the chemistry behind our little magic trick. You got the copper oxide, CuO, and it's reacting with the hydrogen gas, H2. Now, it turns out hydrogen really wants that oxygen, so it basically just swoops in and steals the oxygen atom away from the copper. And what do you get when hydrogen and oxygen combine? Water, H2O. That leaves our copper, Cu, all by its lonesome again, right back where we started.
So it feels like we've seen two totally separate things, right? Copper turns black, then the black stuff turns back into copper. But here's the secret, the real beauty of it all. In that second step, both things were happening at the exact same time.
Let's look at this closely. See what's going on? While the copper oxide is losing its oxygen, that's reduction, remember, the hydrogen is gaining that very same oxygen. So the hydrogen is being oxidized. It's a perfect trade. One loses, the other gains, all in one smooth motion. It's like a chemical dance. And this brings us to the number one rule of this whole thing. It's super important. You can't have one without the other, ever. Oxidation and reduction are basically two sides of the same coin. If one thing is losing oxygen, something else has to be there to take it. And because they're always together, chemists gave this whole process a nickname, a redox reaction. You just squish reduction and oxidation together, redox.
Okay, so if these two things always happen together, it kind of makes you wonder, who's in charge? What's causing the change? In chemistry, we have a name for the substances that do the work. We call them agents.
Let's break it down. It's actually pretty logical. Just ask yourself, what substance caused the copper oxide to be reduced? Well, the hydrogen did, right? It's the one that took the oxygen. So that makes hydrogen the reducing agent. Now flip it. What substance caused the hydrogen to be oxidized? The copper oxide did. It gave the oxygen away. So that makes copper oxide the oxidizing agent. See how that works? Each one is the agent for the other's change. All right, let's wrap this up. What's the big takeaway here? After seeing all this, what's the one thing you should really remember? At its core, a redox reaction is basically a partnership. It's this perfectly balanced chemical duet. You've got a constant give and take. One substance gives an oxygen away, and the other one takes it. The one that gives is reduced, the one that takes is oxidized. And this simple exchange, it's the engine behind so many chemical reactions in the universe.
And you know what? This isn't just some weird lab experiment. Rust on a car? That's redox. A campfire burning? Redox. Even the way your body gets energy from the food you eat? Yep, that's a redox reaction too. They're happening all around us, all the time. So the next time you see something change, like a piece of fruit browning, ask yourself, could there be a hidden chemical duet going on here? Who's giving and who's taking?